coding interview tip that regards arrays and the faster usage of them. In coding interviews, we use different data structures. Data structures that we could use could be the map, it could be the set, it could be lists, it could be arrays, it could be trees and graphs, and etc. But in most questions, we face the basic data structures. Map, set, sometimes also trees, yes, and graphs. But list, maps, and sets and array are really the most common. The thing is this, we are used, the tip is about arrays. When we are thinking about arrays, then we are used to the fact that if we insert something, then we need to insert it into an array. Let's say that we have an array of 20 items, and we insert item on index number 10. Then how much time is it going to take us? Well, if we don't have enough space in the array, and also we need to move all the items because index number 10 it's already taken. So if we insert something to an index that is already taken, then we need to push all the items on the right side of the array, which would be O of n. And the same thing for removal of an item from an array. If we need to remove an item from an array, and we want to keep this array with all the specific items that need to be there, then we need to push to the left all the items over the index that we removed. So we will reach again O of n. And all this means that if we need to insert and remove items from an array on a specific place, this takes us O of n. So this may block us in some kind of coding interview questions where the answer regards where the solution, part of the solution would be an array. Then we would come up with this solution of we're adding items and removing items from an array. And then the time complexity would be O of n. So then the next question would be, okay, so how can you do it in O of 1? How can you do it in single operation, basically? And then you would mind boggle and think, oh my God, because it's in red, right? When I add an item, I need to push everything to the right. When I remove something, I need to push everything to the left. How on earth can be this done? And this is a stressful situation. You need to do this in the stressful situation of a coding interview. How on earth could this be done? Inserting and removing items to an array in O of 1. Is it possible? Or you see what I mean? So then, this is the trick. This is where we come to the trick. This is where we come to this podcast where we provide you with tips and tricks and algorithms and such stuff. And in this case, we're going to see how to add and remove items to an array in O of 1. So this would not always be the case. This would not always serve us well, only on specific cases, but there are many cases, especially if we had it in O of n and we need to reduce it to O of 1, that this specific thing would work. So the thing is this, we need to think when we insert items or remove items from an array. We can insert and remove on the middle, on the beginning, and on the end. If I add an item to an array on the end, how much time is it going to take? So it's going to take O of 1. It's a single operation. We don't need to push anything to the right. So looking at the edge cases, where we need to insert and remove items, bring us to O of 1. If I need to remove something from an array, and this item is on the end, the right side, how much time is it going to take? It's exactly going to take O of 1. Of course, if we don't have enough space in the array, we would need to increase the size of the array, but this would only take place at certain moments in life and not every time we put and remove items from the array. But then you ask, but what if my item is not at the end of the array? What if it's in the middle of the array? How can I remove and add items from the end of the array if my item is on the middle of the array? So the answer is going to be, we are going to switch. Let's say that we need to remove item number 10. At index 10, we're going to switch index number 10 with the end of the array, because the end of the array is index 20. Let's switch index number 10, index number 20, and now we can remove the item that was on index number 10, because now it's on the end of the array. Okay, and what if I had some other data structure that pointed to this item? Then this data structure would need to get updated now that my item is now at index number 10 or at index number 10, the item that was at index number 20. So this was the quick hack for coding interviews on how to remove an end items to an array, even if it whatever, in O of 1 instead of O of n.